This is Dr. Holt. I want to go over this University of Texas problem. Here you have two 98 kilogram boxes that are dragged along a frictionless surface with a constant acceleration of 0.97 meters per second squared as shown in the figure. Now here you have the rope has mass in it. Now you have no friction here, so we don't have to worry about that. To find force, this part's going to be pretty easy. All you have to do here is go back to the summation of forces in the x direction is equal to mass times the acceleration in the x direction here. I'm going to let anything goes this way be along the x-axis be the x-axis. So to do this, all we have to do is set the force F. We set it equal to the total mass. Now we take the total mass of the entire system. So to do that, that's going to be 98 plus 1.09 plus 98 plus 1.09. When we do that, that'll give us 198.18. So that'll be our mass, and that's in kilograms. Now you have your acceleration, which is given as 0.97. Okay, so that's going to immediately give you the force of 192.23. Oops. Do that again. 192.23. I'm going to show all the decimals, all the digits, only because this is University of Texas problem, and that would be the force. Now the second one says find the tension in the leftmost rope at a point where it's attached to the box. So we're looking right here. The easiest way to do this is just draw a free body diagram of this object here by itself. Let me scroll down a little bit. Don't want to go into that other problem. I'll erase this. Alright, I'll draw my force diagram, my free body diagram. I'll have a value coming down here, a value coming down here. It has a mass of 98, so 98 times 9.8. Okay, so that's going to give me the force of the gravity of the Earth on this object would equal to 960.4 newtons. My force normal here would equal to 960.4. Now these values aren't really useful to you because you don't have friction. The only other force that we have pulling here would be pulling to the right, and that's going to be the force of the rope. We'll call it R1, meaning rope 1 onto the 98. And then all we have to do is off to the side, I like to do this. This is going to be my mass times acceleration. And we know our acceleration, so we take 98, which is our mass, multiply it by 0.97. And now just solve. That's all you have to do. Summation of forces in the x direction is equal to mass times acceleration in the x direction. I will get the F at the rope 1 on the 98 must equal to 98 times 0.97. On that number, it gives me 95.06 newtons. And that's how you're going to do that one. Okay. Alright, find the tension in the leftmost rope at the point where it's attached to the right box. Okay. Now we're going to do right here. To do that, all I'm going to do really is draw a force diagram of the rope itself. Now I'm not going to worry about any normal forces here. We're going to treat this as just by its mass accelerating to the right. So what I would have here would be, this would be the force that the 98 is pulling on rope 1. Now off to this one, this is going to be a force pair here in relationship to what I have here. This is the force here is force of rope 1 on the 98. So this force pair would be the force of the 98 onto rope 1. Now we know what that value is. We know that's 95.06. So right here I'll put 95.06 newtons. Again, that is a force pair. Now again, all I have to do is off to the side, mass times acceleration. My mass is going to be 1.09. Go back to block, sorry about that. Times 0.97. So to find that, I'll have to do again summation of forces in the x must equal to mass times acceleration in the x. I get minus 95.06 plus the force of the 98 onto rope 1 must equal to mass times acceleration. 1.09 times 0.97 gives me 1.0573. Add 95.06 to that, and that gives me 96.1173. Alright. And that's it. On doing this problem again, I think I'm going to stop right there. I'll let you guys go ahead and figure out the other one. You do it just the same approach as on what I'm working here. Alright, and I want to go to one more problem. This was the extra credit problem. I'm sure a lot of you are struggling with this. I'm just going to I'm not going to give it away, but I'm going to talk about how to set this problem up. What I would do first on this one is draw yourself a force diagram, a free body diagram of the 11. And mainly I'm going to help you draw those, and then I'm going to leave it on, and then you're on your own. So first thing I'm going to do, I have a force here, I'm going to have the rope here. This is going to be my F value. Now it says what's the maximum acceleration if the block is not to slide. Okay, so if we want to find maximum acceleration, we got to let the force go to the largest value possible. So this will be our frictional force. So this will be F here, frictional force here. This will be F normal. And this, remember, this F normal is the force that the 3 is pushing onto the 11. We'll work that value in just a second. And now this is going to be the force, gravitational force of the Earth onto the 11. And that's going to be nothing more than 11 times 9.8. That gives 107.8 newtons. So that means this has to be 107.8 newtons. Now if I'm not sliding, I'm going to have to use my static coefficient. We can determine this value by taking normal times mu. So I take 107.8 times 0.8. That gives me 86.24. Okay, we'll make that newtons. Now that does not mean that F is 86.24. Just leave F just the way it is. I'll take out the equal sign here. Okay, that's your force diagram of that one. Now, let's draw the free body diagram of the other one. Actually, I'll do it right over here. Now, if this frictional force, which frictional force is the 3 pushing onto the 11 here, then I'm going to have a force pair of this one going back this way, like this, and this value here, let me get my up to the pen here, is going to be 86.24. Again, that is the frictional force of the 11 onto the 3. Okay, now the hard part, what you're missing here, you have two F's coming this way. You can make it like this and make it like this, or you can just make one vector and make it two F's. But you have an F here and an F here. Because it's pulling this way and it's pulling back this way here. Alright, so now we can also do the normals. Now you don't necessarily have to worry so much about the normals here because you have no friction down below. Now if you would, you'd have to consider that. So I'm not going to spend a lot of time on this. I'll let you, if you want to transpose this onto the 3, feel free to, but you don't necessarily have to because you don't have any friction along the surface here. Now we're going to go over here. I'm going to set up my mass times acceleration here. This would be 11. We know our acceleration, right? Acceleration, no, we don't know acceleration. We want maximum acceleration. So we have 11a here. This value here is going to be 3a. Okay, so now just write your two equations and you should have this problem. The first equation here is going to be minus f plus 86.24 is equal to 11a. The second equation is then going to be 2f minus 86.24 is equal to 3a. I'm going to quit right there. I'm going to let you solve that. You have two equations, two unknowns. You should be able to determine what the acceleration is as well as what the force is. Alright, best of luck.